All right, everybody, we're going to continue our exploration of electrophilic aromatic substitution. And on these two reactions at the top of the screen, the one to the right is the same two reactions as the one to the left, except the order's been reversed, and that actually changes the result. The reason is, in step one going to the right, you're putting a nitro group on the benzene first. I'll put the new group in green. And the one on the left, you're putting a methyl group on the benzene first. Methyl group on the benzene first. CH3. The only reason I put it down there, and this one is I see a carbon down there that's probably used to be the methyl group. And the only reason I put the NO2 up here is because I saw on the other ones, I drew it up there. You could have picked any of the 6 positions for either of these. Neither product is done, by the way. They're half done. You've only done step 1. Step 2, when you have a nitro group on benzene already, the next group must go meta. It's in a category called meta director. So your next group must go meta. The mechanism says why. When you've got a methyl group on the benzene, the next group is going to go ortho for one of the products and para for the other. So the group's a nitro again. Purple for the second group. Ortho is minor. Para is major. And what I think I decided I'm going to do is we're going to do all the products here. Then we're going to do a video with the mechanisms. And maybe I'll make that activity 4B on the same page here. And it'll be worth 2. I like it. So what's going on? We've got meta and para and ortho. And looks like we're taking the ortho product, and a couple things happened to the methyl. One, it got oxidized to a carboxylic acid, and now I see it's a carboxylic acid derivative. We know how to make all the derivatives from carboxylic acid, I hope. We just had a test on it. So yeah, earlier today, we saw the reaction that oxidizes the benzylic position. Does anybody remember the chemicals for that? Oxidizing the benzylic position. Anybody? Did you say chromic acid? She did, but don't put chromic acid here. Give me one of the ways to make chromic acid. She likes the CrO3H2SO4. Don't forget the water. A couple of you in this room forgot the water on the test and lost a quarter point. You can't get that extra oxygen on there if you don't have the water. And you need heat. That's the new thing in chapter 21. Yep, that's a 21 end of chapter reaction. Oxidation at the benzylic position. Video done earlier today. And then you need to make a methyl ester. There's a couple ways you can do that. You want to go the cheap way? Cheap way is methanol, sulfuric acid, and heat. Actually, if you consider the fact that this takes a lot of time, maybe it's not cheaper. Time is money. You could have gone with CH2N2, more expensive reagent, but it's done in seconds. Diazomethane, only good for methyl esters. Hey, look at that, we have a methyl ester. Okay, we've got that. How do you convert this thing to this thing? I'd like to point out this green CH3 is this green carbon here, and it's benzylic. That's a benzylic position. If I can somehow get rid of the H and put a halogen there, then it's SN2 time. Right? Whenever you see an ether, you should be thinking of the Williamson ether synthesis, which is just SN2. RO minus attacks a carbon with a halogen on it. SN2. Can we get the halogen on the benzylic position? We did that earlier today. NBS and heat, or Br2 and heat, or Cl2 and heat. Any of those will put a halogen on the benzylic position. And now it's just time to put the appropriate ether on there with the appropriate alkoxide nucleophile right there. Then you can show off if you want and say, you better use a solvent like DMSO or something like that. You don't have to give me a solvent. I really don't need it. But whenever I want to do an SN2, you know, I like those solvents. Yep. And then I see the other version of chromic acid over here. Here's one way to make chromic acid in blue. And the heat is because this is the benzylic oxidation. This will make chromic acid, and the heat, another benzylic oxidation. And take a look at what you got there. You've got you got your NO2 up there. Where the methyl was is now a carboxylic acid. And you've got that. So this is how we can predict products of EAS. Ooh, not responding. I don't like that. We might not get that comment in our video. Stop